This is not a standalone video, but rather an alternative solution to this one particular problem. For the full video, click this pop-up link in the upper right-hand corner. This was part A of problem number 2 from the 1998 AP Calculus exam. And I'm only actually going to address this part of part A in this video because the rest of it is in the full video. For this free response question, they are not expecting you to show any work. And you're not allowed to do algebra with infinity. So the steps I'm about to show are not proper math, but they are intended to give you a way to understand where the answer is coming from. But I would suggest that you not write this down in the answer area of your AP exam, but you could write it on your scratch paper if you needed to. So we want to find the limit of this expression as x approaches negative infinity. So look at this red x. We will have 2 times negative infinity. See what I mean? This is not proper mathematics. Do not put this in your actual answer area on the AP exam. Meanwhile, this x, this purple x, is also going towards negative infinity. But 2 times negative infinity is negative infinity. In other words, if you take a very, very, very negative number and multiply it by 2, you still have a very, very, very negative number. And for the purple part of this expression, we have e to the negative infinity for the same reason. Now focus on the e to the negative infinity power. This means that the exponent is very large in absolute value, but it is a negative number. So when you have a negative exponent, you know that this will drop the expression down to the denominator. So now we picture this, but e to the infinity is just heading towards infinity. So we end up with this negative infinity over positive infinity, which is an indeterminate form. But all infinities are not created equal. We use the acronym FEPL to help us remember which expressions grow faster. These letters stand for factorial, exponential, polynomial, and logarithmic. FEPL ranks these types of expressions from fastest to slowest growing as we approach infinity or negative infinity. In this case, we have 2x, which is a polynomial, versus e to the 2x, which is exponential. So which one grows faster? Exponential grows faster than polynomial. Remember that the infinity in the numerator is the polynomial expression, and the infinity in the denominator is the exponential. So we have this slower growing infinity divided by a faster growing infinity. This means that the denominator is getting bigger and bigger compared to the numerator. And if the denominator is getting bigger and bigger and bigger, that means the overall value of the fraction is getting smaller and smaller and smaller. So that's why the overall limit is 0. Remember, none of that was considered proper math, so don't write that down in the official answer space on your AP exam. Write that on your scratch paper someplace. They don't need you to show any work for this problem. You would just write the limit as x approaches negative infinity is equal to 0 and move on.